Another kind of ensemble learning method is stagging ensemble learning. So here in stagged ensemble learning, or stagging for short, is an ensemble method that seeks a diverse group of members by varying the model types fit on the training data and using a model to combine predictions. Before discussing the stagging ensemble learning, we have seen boosting ensemble learning and bagging ensemble learning. In the boosting and bagging, the model predictions can be generated with different independent combinations, parallel classification and sequential combination of one classifier with another classifier. But stagging is a general procedure where a learner is trained to combine individual learners. Here, the point is individual learners are called first level learners, while the combiner is called as the second level learner or meta learner. Here we are going to divide the learners into some levels like 0 learner and level 1 learner, followed by the number of levels, say some level 2 learner, level 3 learner. And stagging has its own nomenclature where ensemble members are referred to as level 0 models, and the model is used to combine the predictions is referred to as level 1 model. The combiner is called as level 1. The 2-level hierarchy of models is most common approach, although more layers models can be used. For example, instead of single level 1 model, we might have 3 or 4 or 5 levels also we should have. A single level 2 model that combines the predictions of level 1 models in order to make a predictions. Stagging is probably the most popular meta-learning technique. It's the most popular meta-learning technique. By using a meta-learner, this method tries to induce which classifier are reliable and which are not reliable. So, using training combiners, it is possible to determine which classifiers are likely to be successful in which part of the feature space and combine them accordingly. And the points can be summarized as unchanged training dataset, different machine learning algorithm for each ensemble member, machine learning model to learn how best combine predictions, and diversity comes from the different machine learning models used as ensemble members. And as such, it is desirable to use a suite of models that are learned or constructed in very different ways, ensuring that they make different assumptions and in turn have less correlated prediction errors. And the picturization of stagging ensemble is projected on the screen. This is the training data. Input training data will be given to the model 1, model 2, model 3 and model n. And the combination of these models is called as level 0. So this is level 0, and next we will combine all the outputs generated by these models to here, and this is called level 1. Here the different algorithms will be used in all these model 1, model 2 and model n, and finally the output is generated. So many popular ensemble algorithms are based on this approach. Includes one is stagged models, canonical stagging, another one is blending, and next one is super ensemble. So